Okay. Yeah. So now we are going to see much more example, like how we are programming with the respect to a lambda expression and without a lambda expression. Okay. So I am going to take a multiple example by exploring these things. I am taking one example I have seen into the previous class. Another example I am taking, it is a method one which is like a no return type, and method is a method is a not taking any argument, and a non return type. Now I am taking one more example which taking two inputs, public void sum int a comma int b. Okay, so this is a sum. What I will be do, I will one is explain onto here, and another example I will explain onto the from a scratch. Okay, so in here I would just commented out this code, and I will uncomment this code. Um, yeah. So in here is a method one. It is sum is a plus b. Int a comma int b, and sum is a plus b. We have taken new test, and I dot sum of 10 comma 20. So if I am executing this thing, now sum is 30. It is coming. Okay. So this is without lambda expression. Now if we are writing these things with a lambda expression, how we are writing? I am commenting this code, and I am just okay. In here, it would be the same system dot out dot println. No need of these things. System dot out dot println. In here, we are calling the sum is plus, sorry, plus 10 comma 20. sorry, the sum is plus, we are going to write, it is taking how many argument? It is taking a two argument, that is a comma b. We no need to provide this type parameter, so we are going to write a plus b, a plus b. Again calling 20 10 comma 20. Okay, so saving and running the logic. So we see the sum is 30. It is the same, but we are avoiding some unnecessary middle code. So that is the thing. Another one more example I would explain you. I am creating one new class for this purpose. New class. Okay. Here I am going to find a square. What I am going to find a square. So I am going test demo. Hmm. So in here I am going to take one interface. I am going to take interface name like interface A, any name we can take. So into here one method, public int square, which taking one input as a int, as a x. Okay, so then we are going to write a class demo implements a, then we just write a unimplemented method it is giving. So we are going to return square, so x into x. Okay, in a class text test we are going to create object of this demo class. A is equals to the new demo, and now a dot square of 20 if I am giving. Okay, understood. So class demo, test demo. Okay, under I have created these things. I'm so sorry. Yeah. So test demo. This is a separate class. Should be, otherwise it is taking a, yeah. Okay. So one interface I have taken into their one class which implements their method. And here these things I had given. So while running this program, demo is already demo test I given. Okay, because that class it is in the same package, so we can take a same class name into here. New this class it is not find, sorry. Yeah, Now I will be run. So it is returning, but it is not printing. So I am printing in here. Is so. Yeah, it is a 400. It is printing in here. Okay, so this is a traditional logic for calling a method. So how can we write from a Java 8 like with lambda expression? With lambda expression. So interface should be same. Class demo, this implemented class, there is no need of this class. Okay, so I am removing these things. No need of this implemented class, it is a unnecessarily code. We no need to create this object as well, except of this, which thing, one parameter it is need to be passed. So it is a I am passing type parameter, it is not also need to pass, only the variable, which it is a one statement, no need of a curly braces. It is already written a into a. If it is one statement, no need of this parenthesis as well. Sorry, it is giving the same variable. So x into x. Now in here, a into square of 20. Now, if I am running this code, now it is the same thing. For your reference, if I am giving 90, control X. So it is a 18 one. So you can see like how much simplified code is. No need of middle implemented class, no need of creating that object. If it is interface method, we implement to that method onto the our logic. So again, one program we are going to write uh, as a in case of multi-threaded environment. Okay, so let's have to see in here. I hope this is these things will understand, will clarify your doubts how we are implementing functional interface. Okay, so one more example I would cover in here. Yeah. So runnable is an interface which have only one method, run method. Okay, so we are defining class my runnable, my runnable implements runnable interface. So it has one method. I have implemented that method. It is run method. So in here for in I is equals to 0, I is less than is equals to 10, I plus plus. This one I am printing child thread. Okay. Now I am taking a class thread demo. I will show this example onto a new place. New class thread demo. I will show this logic. Okay. So I have taken Runnable is a predefined class which have only one method, run method. I implement this class through a my Runnable class. Now I am creating a class thread the demo. What is the demo? Okay. I have created a class thread demo. In here I am taking a main method. Okay. Now we are creating to the Runnable. I am going to create my class object which is a Runnable type. Ru double enable Runnable R is equals to the new. Now this thread th is equals to the. Now I need to create a thread class object, new thread, where I need to pass this Runnable, because if we see the thread, so it is taking a Runnable task. Okay, so that's why we need to pass this Runnable reference in here, and we need to start our thread, otherwise thread will not started. It is only we define th dot start. Understood? So these things were happening, and after th dot start we also need to call our for int I is equals to 0, say I is less than is equals to the 10, I plus plus. Here is main thread. Which thread it is? Main thread. So now we executing this program. There is no execution level for a child thread and a main thread. So we see in here is child thread, main thread, main thread, main thread, then main thread, child thread. If we again run, then child thread, main thread, child thread, main thread. So for multi-threaded environment, there is no particular execution. Which thread is executed first and which thread is executed last. Okay, we can give the priority but that is a thread concept, multi-threading concept. So if you people want, I will be explore that one as well. So it is a concept without a lambda expression. So what we have seen, we have created a class which implements a runnable interface, then we override that run method, we write our logic, then our implemented class, we created our in our test class, we created object of our implemented class with the interface type, reference variable type. Then we created a thread class object, we passing this our this reference variable onto this our in a thread class constructor, then we calling a start method. Okay, and then only this thread is initiating. So this much logic is is needed if we are not using a function lambda expression. So we can also write only this much of logic, one method, right? So no need of this many things, these many steps are required. We can simplify this logic by using a lambda expression. So how we are writing these things onto the lambda expression? Very simple. These things are, it is not required. First thing, so I am commented out because middle class means implement class, it is not required. So in a class thread demo, in here we need a enable r, we no need to create a my implemented class objects. Only what we need, we just passing, we need to write our logic in here. So this much of things what we have write in here for this logic, correct? Copy this thing and paste these things in here. So yeah, and now we are passing these things. So this is a lambda expression for this multi-threaded environment. If I am running, something is breaking. What is this? Yeah. So for mm, yeah, then Okay, so these things now we are running. So we can see no need of writing onto the middle like a implemented class. So in the implemented place only we have writing this is a lambda expression for these things. So in that way we can reduce our code. Understood? So this is all about lambda expression. Thank you. Thank you very much. So in the next chapter, we will learn anonymous inner classes versus a lambda expression. Okay. So wherever we are using a anonymous inner classes, there may be a chance of using a lambda expression to reduce the length of the code and to resolve the complexity. So anonymous inner class, all people know, nameless class. It is a anonymous inner class. So, but